Hello guys, welcome to our channel, McCourt Engineering Information. Hope you all are doing well. In today's video is gonna be about operating system in computer science, so let's get right into the video. If you don't subscribe to our channel, please subscribe and share the past videos and new upcoming videos. Let's start. System. An operating system (OS) is a collection of software that manages computer hardware resources and provides common services for computer programs. When you start using a computer system, then it's the operating system (OS) which acts as an interface between you and the computer hardware. The operating system is really a low-level software which is categorized as a system software and supports a computer's basic functions, such as memory management, task scheduling and controlling peripherals etc. This simple and easy video will take you through step-by-step approach while learning operating system concepts in detail. An operating system (OS) is an interface between a computer user and computer hardware. An operating system is a software which performs all the basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives and printers. Features of operating system. Operating system has the following features: convenience. An OS makes a computer more convenient to use. Efficiency. An OS allows the computer system resources to be used efficiently. Ability to evolve. An OS should be constructed in such a way as to permit the effective development, testing, and introduction of new system functions at the same time without interfering with service. Throughput. An OS should be constructed so that it can give maximum throughput number of tasks per unit time. Major functionalities of operating system. Resource management. When parallel accessing happens in the OS means when multiple users are accessing the system, the OS works as resource manager. Its responsibility is to provide hardware to the user. It decreases the load in the system. Process management. It includes various tasks like scheduling and termination of the process. It is done with the help of CPU scheduling algorithms. Storage management. The file system mechanism used for the management of the storage. NIFS, CFS, CIFS, NFS are some file systems. All the data is stored in various tracks of hard disks that are all managed by the storage manager. It included hard disk. Memory management refers to the management of primary memory. The operating system has to keep track of how much memory has been used and by whom. It has to decide which process needs memory space and how much. OS also has to allocate and deallocate the memory space. Security. Privacy management. Privacy is also provided by the operating system by means of passwords so that unauthorized applications can't access programs or data. For example, Windows uses Kerberos authentication to prevent unauthorized access to data. The process operating system is user interface, user, system and application programs. Operating system, hardware. Every general-purpose computer consists of hardware and operating systems, system programs, and application programs. The hardware consists of memory, CPU, ALU, I/O devices, peripheral devices, and storage devices. The system program consists of compilers, loaders, editors, OS. The application program consists of business programs and database programs. Operating system generations. Operating systems have been evolving over the years. We can categorize this evaluation based on different generations, which is briefed below. Zeroth generation. The term zeroth generation is used to refer to the period of development of computing when Charles Babbage invented the analytical engine and later John Atanasoff created a computer in 1940. First generation. 1951-1956. The first generation marked the beginning of commercial computing, including the introduction of Eckert and Mauchly's UNIVACI in early 1951, and a bit later, the IBM 701. Second generation. 1956-1964. The second generation of computer hardware was most notably characterized by transistors replacing vacuum tubes as the hardware component technology. The first operating system (GMOS) was developed by the IBM computer. Third generation 1964-1979. The third generation officially began in April 1964 with IBM's announcement of its System 360 family of computers. Hardware technology began to use integrated circuits (ICs), which yielded significant advantages in both speed and economy. Fourth generation 1979 present. The fourth generation is characterized by the appearance of the personal computer and the workstation. The component technology of the third generation was replaced by very large-scale integration (VLSI). Many operating systems which we are using today like Windows, Linux, macOS etc. developed in the fourth generation. Operating system types and examples. General Purpose Operating System. A general purpose OS represents an array of operating systems intended to run a multitude of applications on a broad selection of hardware, enabling a user to run one or more applications or tasks simultaneously. A general purpose OS can be installed on many different desktop and laptop models and run applications from accounting systems to databases to web browser to games. Common desktop operating systems include the following. Windows is Microsoft's flagship operating system, the de facto standard for home and business computers. Introduced in 1985, the GUI-based OS has been released in many versions since then. Mac OS is the operating system for Apple's Macintosh line of PCs and workstations. Unix is a multi-user operating system designed for flexibility and adaptability. Originally developed in the 1970s, Unix was one of the first operating systems to be written in the C language. Linux is a Unix-like operating system that was designed to provide PC users a free or low-cost alternative. Linux has a reputation as an efficient and fast-performing system. Mobile operating system. Mobile operating systems are designed to accommodate the unique needs of mobile computing and communication-centric devices, such as smartphones and tablets. Mobile devices typically offer limited computing resources compared to traditional PCs, and the OS must be scaled back in size and complexity in order to minimize its own resource use, while ensuring adequate resources for one or more applications running on the device. Mobile operating systems tend to emphasize efficient performance, user responsiveness and close attention to data handling tasks, such as supporting media streaming. Apple iOS and Google Android are examples of mobile operating systems. Embedded operating system. Not all computing devices are general purpose. A huge assortment of dedicated devices, including home digital assistants, automated teller machines, ATMs, airplane systems, retail point-of-sale POS terminals and Internet of Things IoT devices, includes computers that require an operating system. Network operating system. A network operating system (NOS) is another specialized OS intended to facilitate communication between devices operating on a local area network LAN. A NOS provides the communication stack needed to understand network protocols in order to create, exchange and decompose network packets. Today, the concept of a specialized NOS is largely obsolete because other OS types largely handle network communication. Real-time operating system. When a computing device must interact with the real world within constant and repeatable time constraints, the device manufacturer may opt to use a real-time operating system (RTOS).